Greetings, traveler. I am the Calculus Cleric, and today we'll be going over series. I'm not going to spoil what kind of series it is yet. And so they're asking us to get this expanded notation series and get us to turn it into its sum. Okay, so to do that, we probably want to start off with sigma notation. Now, -2 to the n over n. This is giving us what is called our a of n value because it's the nth term of a sequence. And so that's what our sigma notation is going to look like. Now you might recognize this style of sequence or this style of series, and it's commonly used for when a series is equal to e. So x to the n over n factorial, this is equal to e to the x. So similarities are quite striking because they're almost the same thing, except the x is substituted out with -2. So we can actually do the same thing, and because they're substituting an x for a -2, we just have to substitute the sum x with a -2 as well. So this works perfectly fine. As long as we remember to start at n is equal to 0, not some other number, because then substituting will no longer work. So e to the -2 is 1 over e squared. Now I might be tempted to choose option B, but that's not really the case here, because remember we have to start at n is equal to 0. So now you'll be asking, why is that not the case? Well, let me show you. When I take the term n is equal to 0, when n is equal to 0, this will give us a value of 1. So it clearly does not start at 1. It starts at 2. All right, so when n is equal to 0. So let me keep going until I hit actually 2. So n is equal to 1, -2 to the 1 over 1 factorial is equal to -2. Still not there yet. And then n is equal to 2, -2 squared over 2 factorial. This is equal to 2. Now, if I got one more, just to prove that the next term is indeed in line with this pattern. So to the 3, -2 cubed over 3 factorial is equal to -8 over 6, which is equal to 2, 4, 8, 2, 3, 6, -4 thirds. So indeed, that is the next term on the list, and it lines up quite nicely. But what about this 1 and 2, you might be asking, because that's clearly not in the series. So we need a way to get rid of them somehow. So basically what they are is they are placed in front of the series that we have. We can sum these up, giving us a value of -1. Basically what we have to do is we have to somehow cancel this -1 out. We know that we can add 1 to the entire series to cancel out the -1 that is here in this sequence. And after we add 1, they'll total up to 0. But if we add 1 to one side of the sequence, then we'll have to add it to the other side. So it's sum. And as we recalled saying, the sum of this over here, the whole thing, including the 1 and the -2, is 1 over e squared. So because we added 1 on one side, we're going to have to add that same 1 on the other side. And when we simplify this out, when we combine them into a single fraction, giving them a common denominator, we'll get e squared plus 1 all over e squared. So that is equal to d.